Uh, Hello, everyone. Today, our team will be presenting our final project, Project Metro Bank. Our team members are Alexander Liss, Gavin Birk, Rama, and Victor Huynh. Metro Bank is an online banking system designed to serve customers in the DMV area. Throughout this presentation, we will explain our system requirements, our backend design, user experience design, diagrams, and how AI contributed to our project. So this is the presentation agenda I'll be going over real quick. So first we will cover phase 1, which focuses on the requirements. Phase 2 focuses on backend development. And phase 3 focuses on our user experience development. So phase 1 overview. So for phase 1, we focus on defining the foundation of our system. This included identifying the system name, domain, and scope, explaining the problems Metro Bank is meant to solve, identifying stakeholders, creating system requirements, developing use cases, and creating data flow diagrams. We also had to document how AI helped us brainstorm features and improve our overall project. So our system name and domain. So our system name is Metro Bank. Metro Bank is an online banking system designed to serve the DMV area. The system allows users to manage checking accounts, savings accounts, credit cards, and loans. However, Metro Bank does not support cryptocurrency transactions or stock market transactions. So Metro Bank scope. The scope includes several major banking functions. Users can securely deposit checks through the mobile banking app, can create accounts fully online using two-factor authentication or 2FA, and apply for credit cards or loans online through the mobile app. So they can also transfer money between Metro Bank and external bank accounts, view and redeem cash, and process transactions through MasterCard or the Visa payment network. So Metro Bank's problem statements. Metro Bank is designed to solve several common banking problems. The first is the traditional limited hours of operation. So traditional banks may only be open during business hours, but Metro Bank provides 24/7 service, so our customers can access their bank accounts at any time of the day or night. The second problem is inefficient banking transactions. So Metro Bank uses a fully digitalized system which makes banking faster and more convenient. The third problem is a human error. So since transactions and balance calculations are digitized, this removes the human element that can contribute to basic human errors, that occur in everyday life. So Metro Bank also includes a large ATM network, no ATM fees, which is probably our biggest selling point, and a convenient mobile app and website for checking balances. So our stakeholders. So we have several types of stakeholders. Several stakeholders. So the first external stakeholder is the account holder, which are our customers. The second is financial regulators. And the third is the payment network itself. The third external stakeholder is the payment network, such as MasterCard or Visa. So their role is to process Metro Bank credit card and debit transactions while making sure Metro Bank follows their standards in terms of service. So our internal stakeholders. So Metro Bank also has several internal stakeholders. The first is the system administrator. The second is the infrastructure development team. And the third stakeholder is the customer support team. So for the sake of time, I'm going to skip that slide, but you guys can read off that, as you please. So our system requirements. So Metro Bank's system requirements includes both hardware and software, in addition to encryption. So I think the point I want to highlight here is the encryption, since banking is pertinent information, PID, as well. Banks and the banking system as a whole are a huge target for outside attacks. And the banking and banking information represents some of the most profitable targets that unethical outside hackers will try and attack and gain access to. So security and encryption is probably the most important part to ensure that their system continuously runs smoothly and that the trust that they build and develop with their customers maintains. So so the system requirements. So Metrobank's system requirements include both hardware and software components. So for software, the system uses a 256 SHA-256 hashing algorithm to help protect sensitive data. For hardware and infrastructure, Metrobank uses high-performance cloud servers, encrypted backup storage, AWS cloud servers, satellite VSAT, and secure satellite communications. And these requirements, they support security, reliability, and system availability. So this is Metrobank's use case. So Metrobank includes several main use cases. Users can register for accounts, log into their Metrobank account using 2FA, view account information, transfer funds, deposit checks, redeem cashback, and apply for credit cards or loans. The system also includes administrative and regulatory use cases, such as generating compliance reports. So this is our context data flow diagram. So at the center is the Metro Banking online system. The main external entities are the account holder, the external bank, the payment network like Visa or MasterCard, and financial regulators. And for the sake of time, I'm just going to move on. So level 0 data flow diagram. So this slide shows a more detailed level 0 data flow diagram. So the system is broken down into major processes, and I know it might look messy, but it all makes sense. So for the sake of time, I'm going to skip this slide. So AI contributions for requirements. So AI helped us in a multitude of ways, to plan the requirements phase. So we used AI to generate simple data flow diagrams, get feedback on the entities chosen, and brainstorm additional features that we wanted to include in Metrobank in the design or the conception of Metrobank. So AI was useful because it helped us organize ideas, identify missing details, and improve the clarity of our system requirements. So phase 2 overview. So in this phase, we created several UML diagrams, including a class diagram, a sequence diagram, state chart diagram, use case diagram, and an activity diagram. And we're also going to go over how AI contributed to this. So this is our class diagram. So there's a user class, an admin class, customer class, account class, and a loan class. And this is just a basic idea of how Metrobank works. Because me personally, I didn't want to, go and create this massive chart that just, looks very messy and unorganized. So the loan class here can be replaced with a transaction. It can be replaced with, the multitude of different services that Metrobank offers. So the user class represents basic user info. The admin and the customer class are related to the user class, with admin managing customers and customers having accounts and loans. And another thing is that we wanted to start off This by making everybody a user. So admin gets registered in the beginning as a user, and customer gets registered in the beginning as a user. So this is our sequence diagram. So our sequence diagram, it shows the process of how a customer would transfer funds through their account. So the main participants are the account holder, which is the customer, transfer services, account, and transaction details. So the account holder begins the transfer process. The transfer service checks the account and verifies the balance. If the balance is available, the system debits one account, credits the other account, records the transaction details, and then returns the transaction status to the user. This shows a step-by-step interaction between system components during a transfer. So much like our previous diagram, the class diagram, this just shows the transaction. So this is one of the many services that we offer here at Metro Bank. And we just wanted to give, any potential stakeholders or any potential investors an idea of, a very basic idea of what one process would look like. So this is our state chart diagram. The user begins at the login screen and enters their credentials. If the credentials are valid, the bank dashboard is displayed. If they are invalid, the user is returned to the login process. So from the dashboard, the user can choose to transfer money or apply for a loan. The system then approves the loan or transfer, updates the user account, and eventually logs the user out. So this diagram, it helps us show the different states the system goes through during a banking session. And this is more of an in-depth look into, more of the functions that Metro Bank offers. So this is our use case diagram. So our use case diagram shows the main actors that interact with Metro Bank. The primary actor is the account holder, who can register online, log in, view information, transfer funds, do anything within that Metro Bank offers within their system. So other actors include the payment network, which facilitates traffic on the network regarding payments. Financial regulators who need compliance reports that we are following, all the FCC and SEC laws, and the use case, external bank and ACH networks. So this use case diagram, it helps us show what each actor can do in the system and how those actions connect to Metro Bank services as a whole. So this is an activity diagram. So our activity diagram, it shows the transfer funds process using swim lanes. So a customer starts, they log in using their credentials. The online banking system then validates the login credentials, and the dashed line with a white page with the corner tucked, that is I believe it's an artifact. So that is a separate place where data is stored that the system is accessing, which is why it's a dashed line. It's like a database or, a file that the system uses to, go further in the processes. So there are two swim lanes: the customer, the online banking system. Again, the customer logs in. The system then has to validate their credentials. If no, then they send an invalid login message, and then the process restarts. If it's yes, then you output user financial dashboard. The system outputs the user financial dashboard. and then the customer submits transfer funds. The customer enters transfer details, and then the customer submits a transfer request. So this was the AI contributions for our diagram. So we used AI to generate system features and actors, receive feedback on our state chart diagram, and get feedback on diagram relationships. So this helped us improve our UML diagrams and make sure our relationships, our actors, and system processes were more accurate. So this is phase 3, which focuses on the user experience and user design development. So this phase includes dashboard design, input forms, our main page design, HCI and UX considerations, database design, storyboard, and wireframe navigation, and then how AI contributed to the whole thing. So this is our dashboard design. Our dashboard design, it's intended for an admin user. So the dashboard tracks key performance indicators and provides an overview of user activity logs. Admins can use it weekly to review how the system is performing and how customers are using it. It can also be used for quarterly reviews to show trends over time. So this dashboard, in addition to doing all that, it helps management monitor system performance and tracks and logs customer activity. So this is an account creation input form. So this slide shows the form, which includes real-time error handling, a date picker, and number-only inputs for fields such as income and social security number. It also shows radio buttons for gender, green confirmation checkboxes for completed sections, and a search bar for filtering states. Like what state you live in, not like state of the transaction or anything. So for account details, the form includes a drop-down for account selection, number-only inputs for deposits, and password error handling. And then all these design choices, they were made with the idea or the intent to make it easier for the user to use and prevent, mistakes. So this is our transfer funds form. So the form includes drop-downs for account selection, a swap account button, and a progress bar that shows the portion of money left after a transfer. It also includes a memo field with transfer suggestions and radio buttons for receipt preferences. After the transaction is complete, the user sees a green transfer successful screen showing transfer details, which is in the on the right, the picture on the right. So this gives the user clear feedback and confidence that the transaction was completed successfully. So this is our main page design, and it was created for a mobile banking experience. So it uses a responsive layout that scales to different screen resolutions and screen sizes because no two phones are the same. The interface also uses touch gestures to help users navigate through the app. And this makes the system more accessible on mobile phones, tablets, and desktop computers. So HCI and UX considerations. Dark backgrounds with light foregrounds. They improve visual clarity. Form inputs include example text to guide users during data entry. Clear error messages displayed to guide users. And for the sake of time, I'll let you guys read those next 3. So this was our database design. And again, when you see transaction, that transaction will then branch off into, all of the functions that Metrobank offers. But we just wanted to give you guys, a broad idea of how we get to that point in the process. So for database design, it's intended for upper management. And what upper management will do with this is, since upper management already knows the in and outs, they'll use this to help train new employees or interns. And not in addition to training, the new employees and the interns can also refer back to this diagram in case they have any questions or issues with um, you know understanding how Metrobank works. So this is the storyboard design. Our storyboard design shows the navigation flow for Metrobank mobile app. So it begins with the login screen where the user enters their email and password and also completes the 2FA. So then the user reaches the main account dashboard where they can view their balance, quick actions, and recent transactions. And from there, the user can move to the transfer funds screen, enter transfer details, and submit a transfer. So the storyboard helps show a user how a user would move through the app step by step. And again, these are the AI contributions. And that is the end.